Perfect. So thank you again. Thank you very much for having me here. Don't be afraid. I am not going to spend a lot of time with the slides. I'm just going to set up a context and share some, how did I get here to do this? That's myself, Bruno Capuano, born and raised in Argentina, lived in Spain 11 years. That's why the funny accent. Moved to Canada with the family 6 years ago, and I've been working with Python for 5 or 6 years, mostly on machine learning. Today, I'm going to show you how to play around with this very small and crappy drone. This is not a professional drone, and I will tell you how, and I will tell you how we can do this. But the idea is to basically show you how we can create and connect and control the drone from scratch. And once we have access to the drone, what else we can do? And of course, I'm working Microsoft as a cloud advocate. I joined Microsoft 3 months ago, not a long time ago. And hey, I love to tinker around with technology. I love to play around and learn. And I find also that Python is a great language to do this. Full disclosure, I've been working with C# and C++ for 20 years. As I said, I started to play around with Python mostly for AI and machine learning, and I love it. I switch it, and I love it, and I do a lot of stuff. And most of the stuff I'm going to do today are going to be a mix between Python and OpenCV. If you already know OpenCV, it's going to be super easy. If you don't know OpenCV, don't be afraid. I learned it, I can do it, so it's going to be easy for everyone. And finally, as I mentioned, I'm a dad, so I do very bad jokes. My demos are not very good, and the animations are... sorry about everything that is not super professional here. This is just for fun. Do not put this in production, really. And how did I get here? So 2 years ago, or yes, probably 2 years ago, sorry, I have a very good friend here, and he told me about this drone. This is a 100 Canadian dollar drones, which is probably 70 something in the US. And if you get to Black Friday or whatever date, you are probably going to have this with some discounts. So it's kind of a very not expensive drone. It's a toy. It's called Rise. DJI, Tello, they have different name. It's from Tello, it's from DJI. They have professional drones. And he told me that, hey, you know this drone? This is a super cool drone. And I was starting to play around to see what we have. So it's not a professional recording, whatever drone. So you have 10 minutes of batteries. You have a Wi-Fi connected with 2 antennas. You have a camera 720p of quality. So it's a toy. It's mostly a toy. But when we were talking about this one, this got my attention. I saw that in some places, DJI, they run this educational program, and they invite kids to program and control the drone, and control this drone. And they use Scratch. Probably it's a super popular environment for programming for kids. It's not a language. It's basically you connect blocks. And as you see here in the left, you can say something, a kid can say, okay, what do we want to do with the drone? We need the drone to take off, then to move right, to do a flip or whatever, just connecting blocks. And then they press play and the drone will do that. So, oh my God, I love it. And I say, hey, you know what? $100 drone and with an SDK, that's great. That's something that I want to play around. Also, in the DJI Educator program, they have the simulator, they have a lot of stuff. They even have this Iron Man branded drone and other skins. Again, it's super small, so you will see people creating with 3D printers, a lot of kind of custom whatever for the drone. So I said, okay, I can do it. If it has an SDK, I can program the drone. Full disclosure here, most of the time, if you have a kit, a set of APIs to program a drone, we are talking about expensive drones, a couple of $1,000 drones. So have the chance to play around with a cheap one. It was something that I want to give it a try. But I faced the reality. There is no SDK. There is nothing there. The only thing that you can find is a PDF that basically will explain how you can connect to the drone And once you connect to the drone, how you are going to open a couple of ports, and how you can send commands via UDP. UDP is a communication protocol that you can send command to the drone. So you can say to the drone, hey, drone, take off, move right, move left, move up, down, flip, do these kind of things. So with this in mind, I basically learned that we have, when we connect to the drone, we have 3 ports. One port that we need to open to send command to the drone, another port to read information from the drone, like battery level, time of flight, accelerometer information. The drone has an accelerometer. And the third port is to access to the camera. With this in mind, I basically say, okay, I can do something. I never work in Python with ports and this kind of stuff, but I can set up something and I can build something. And this is what I am going to show you. This is the last of my slides. But before moving there, let me show how I am going to do this, because we are going to see how I connect and disconnect to the drone a lot of time. Remember, this is a toy. This is not a professional one. It's not created to fly and do these kind of things. So what I have right now, I have my PC connected via network cable to the internet, and I am going to connect to the drone using wireless Wi-Fi. When I turn on the drone, I am turning on the drone. You're not going to see anything, just a blinking LED on front. Don't care about if you don't see the LED, but it's just blinking. But at this moment, what I will see here in Windows or whatever OS that you are using, somewhere here, let me go back again, in the Wi-Fi and the wireless network, I will see this. I will see a new network with the name is Telo and random number, which is probably the ID, serial number, or whatever of the drone. And I can connect to this network. I am not going to connect this using Windows, because Windows will connect to the network, detect that the drone is not having internet connectivity, so it will disconnect. So I am going to go old school here, and I am going to use this command, which is basically said, hey, Windows, connect to a wireless network, and the name of the wireless network is Telo, and the random number. And on top, what you see here, I have, let me stop it. I know the IP address that the drone is going to give me back. So I am going to do an eternal ping to connect to the drone. And once I am connected, I will have some reply from the drone. So it's turning on, yes, it's on here. After a couple of seconds, you see here that starting to reply. So I am connected to the drone. Right now, I am connected to the drone and I can start to do stuff. I'm just showing this because during the demos, the drone will get disconnected. I am going to show the camera and it's going to freeze, it's going to broke. So I need to go back here, see if I am connected or not, and connect again. But again, this is not a professional drone. This is a toy that we use to learn a couple of things. And this is my setup. I know, remember, it's not a professional one. This is just to learn and fly. And if we were lucky and we were in a room and we can make a real demo of the drone, the hello world of the drone will be something like connect to the drone and make it fly. Here, I am going to do the hello world, just showing the battery information for the drone. And I will leave the flight demos at the end, because I learned in the bad way that if I start making the drone fly, hit the wall and break the drone, I need to say goodbye. So I don't want to stop my demo right now. I will do something else in the middle until we get here. So last slide here until the recap. Let me show you how I can connect to the drone and what we can do. So environment, what I am going to use, I am going to use Python. I can't remember which version. Let me show here what version do I have. 3.711. But if you have the latest version and you can install OpenCV, that's good enough. But this is the one that I have for my demos. But again, it should probably work in 3.9, or I don't know if OpenCV has 3.10, but 3.7 and OpenCV is the minimum that you need. And what I am going to do, I am going to create a very simple file, demo.py. I am working in code. Visual Studio Code, and let's start with some imports. As I mentioned, first 3 stuff that I'm going to do, sockets. I need to work with sockets. I'm going to connect to the drone and open three sockets to the drone. So I need to work with the library for sockets. Time, you're going to see the crappiest code ever to manage timeout. Do not do this at home, but it works for me. And threads. I am going to open each one of the sockets in different threads so I don't block the main application. This was cool for me the first time that I did it because, again, I was working a lot with a lot of machine learning libraries. I never worked with sockets or threads or other stuff, so it was nice to see, oh, I can do this and that. It was a great learning experience. So that's the main imports that I'm going to use. Then I am going to later open a socket, client socket, and I am going to do an eternal loop. Remember, don't do this at home. But I am going to basically, hey, socket, give me chunks of data, 124 bits at a time. So that's going to be my response. I am going to read information here. This is the one when I send the command like take off or move forward or back. This is going to reply OK or error. No details. You don't know what's happened. Also, this is UDP. If you don't know how UDP works, it's very different than like TCP when you send them, when you connect 2 parts, they make a handshake, so you have the connection and you can send the message to know the message is here. In UDP, you basically throw message and you wish for the best. You wish that the messages are right in order, but you don't know if they are there or not. Here, we also don't know if the drone process or not, but hey, one socket to read what's happened, and the other socket, and this is interesting, which is the state socket, that is going to give me a full string with a lot of info, as I mentioned, that is going to be the battery, the time of flight, accelerometer, and a lot of other information. And it's going to be cool because I can split this info. It's going to be connected using semicolons. And I can, basically, I will know that, in example, the battery value, when I split this, is in the item, the number 21 in the right. So play, and this was a test and try and learn where I get this, but with these 2 functions, receive data and read state, I can read information from the drone. The next step will be, okay, how do I send commands to the drone? And this is, again, super easy. I have a global variable. This is going to be response, the one that we read before. I will get a timestamp right now to see what's happened, and I will send the command. Important, I learned that we need to convert the command string to UTF-8, character and encoding, because this is what it is. And then I will define the address later, which is basically the IP and the port that I need to send here. And I will have a while until I have a response, or I have 5 seconds as a timeout. Again, this is not the best way to control a timeout, but it's a very simple pattern, and I like it because it's easy to understand. You get the time at the beginning, send the command, and check your response for 5 seconds. If everything works, you return the response, otherwise, false. Here I have some kind of overlords of the main function where I'm going to convert the string of the response, and the response also, to string, or basically, to check if it's okay or okay to see if it's true or false. So it's kind of a couple of overloads for the beginning. By the way, this is not necessary anymore. It's always going to be lowercase, but this was plain and learning. But this is kind of the main function. I can read information for a socket, and I can also open the socket and send command to the drone. And again, which commands are we going to send? The commands defined, the commands defined in this PDF that you can download online, and somewhere here, you have the commands, you have command, take off, land, stream, emergency, a lot of commands that you can use. By the way, I'm going to share the code, share the PDF, share the slides, everything when we finish. So if someone wants to play around, you can start and use it there. So going back to the code, I have my read information for the drone functions, send information for the drone functions. Next step, it should be easy. Let's connect to the drone. and I know my IP. I already connected with the wire using the wireless, so I know that IP that I'm going to use. I know the couple of ports because the PDF know what we have to do. So I have here my address using UDP on port. And the only different stuff that I am doing here, fit it here, yes. I will open, as I mentioned, 2 sockets, one to send information to the drone and the other to read information for the drone. We are almost there. My next step before reading the app is to basically run these 2 receive functions in different threads. So I'm going to create 2 threads here in daemon mode. That means that they are going to run side by side with the main application and they're going to be connected, but they are not going to bother each other. So I can interact with them in a very easy way. By the way, I've been working with threads for 20 years in C++, in Java, in C#. Python is the easier environment, is the easier place that I can really find working with different threads. It's not a happy experience. This is amazing. I love it. I am crying when I need to go back to C++ and try to do something like this. Very, very small side note there, but I need to say it. I was super happy with 3 lines, only 3 lines, and everything was working and working fine. So I have my threads here. So I have my function working differently. Let's write an app. Let's write a super simple app. And this is going to be the logic of my app. I will define a battery, variable 0. I am going to send the first command that is going to be command. This is something that is described in the SDK. When you connect using and you create your own application, you need to send this string so the drone knows that it's going to work in a non-official DJI Tello app. And then I'm going to read the battery value. This is also something that is described in the SDK. You have a couple of literals, strings here that you send to the drone, and the drone will refresh the battery, the altitude, the time of flight, and all of these. And then I'm going to print the battery. So in the first 92 lines of code are kind of my SDK. I write 10 lines to run this. So let me copy this. I am going to run this in the console, so I know if I am connected or not. So that's where you are going to see me. I am not connected. You're going to see me doing this all the time. So I turn on the drone. There it is. I'm going to send the connect command. Once I have the ping, I will run my application. So one more time. There it is. I am connected. So I'm going to go back here. Go here to, this is the, this is the file that I just created, and I can do python demo.py. And what is happening right now, it is connecting to the drone, waiting 5 seconds, and it's going to show me that the battery is 85%. So I know the most boring demo ever. Just connecting to the drone, just connecting to this and show the battery value, but I can change here 2 lines of code. So let's run this for 25 seconds. And here, when we are reading information from the drone, let's print the list. So what I am going to do here, I am going to run the same app, but every time that this thread is going to get information from the drone, I'm going to print this info. So if I go back here, I'm still connected, yes, and I run again this, you will start to see info. And I can, if I start to move the drone around, I don't know if you see that also the console is moving. This is because one of the values that I have here is the accelerator. So once it's finished, 20 seconds, so it should be finished right now, we can start to check all of the info that I get from the drone. So what you see here, let's wait a second, it's finishing. Let's take a look at what we have. And again, so sorry, it's a lot of info. So I have pitch, roll, and yaw. This is basically the 3 axes that the drone is right now. I have a vector, again, X, Y, and Z. I have the temperature low and temperature high here. in Fahrenheit, so 77 and 80. Sorry, don't speak Fahrenheit, don't speak inches, don't speak any non-metric stuff, but I know that 70 something and 80s is good enough. The time of flight I also have here, and I also have the battery that I showed before, 83%, and I have the barometer, a time, I can't remember what is the time. Sorry about that. And then I have these that I'm going to use later, which are the accelerometer, AX, AY, and AC. And this is the values that they were changing when I was moving the drone. So 100 lines of code, and I connected here, and I started to read information from the drone. If we were in a face-to-face environment, I will put the drone on a flight, and I will send the command take off, flight, take down, and land later. I'm not going to do this right now. I don't want to break the drone. And I see that, Mike, you have raised your hand. If you have a question, please unmute yourself and go on.
Yeah, just real quick, and I see Amelia has a question as well. My question, I think you might have already answered. I was looking at the original demo code and your demo Py script, and I saw that for command, you were using the double quotes, but for issuing the battery request, you were using the single tick marks. It looked like it didn't matter in the end because when you ran the demo, it still worked. So I was just wondering, if there's a difference in certain ways that you send the commands, the certain commands need to use the single ticks versus the doubles, or?
No, I mean, it's the way that Python works with strings. So no, yes, you are right. I have here double quotes and single quotes because I convert everything to string, and Python was very nice. I can't remember, probably the Python experts here can help me. I can't remember. I know that in Python 2, when I open the Python 2 samples, I need to work a lot fixing strings. Here in Python 3 and on, it's much more easier. But no, for these demos, really don't care about this. Again, okay, this is a bad sample of codes. I should be coherent and use double quotes everywhere, single quotes everywhere. But hey, this is fun. I'm learning while I type in, so this is what you are going to see. But if the question is one or the other, for these scenarios, it's all a string and the end.
Yeah, you use the other programming languages where that sometimes can really matter. Like you mentioned C++ earlier, and it's like hardly anybody wants to go back to C or C++, right? Yes. Remembering all those little differences, it can really
because in C++ or even in C#, the single quotes are usually where you work with characters, and the double quote is for strings. So it's completely different. Here, no problem. And as I said, this is good enough to work. And again, this is just 10 lines of code, and really it's 4 or 5 to do something, and I have 90 at the beginning to control the drone, to connect, but everything, what's happening in the back, translating this to string, it's all managed by Python. And by the way, I didn't have the chat open, I just opened this. If someone else has a question, feel free to raise your hands or do something. I will also check the chat. Sorry if I missed something.
Yeah, Amelia has a question. Go ahead, Amelia.
Okay, I finally figured out how to unmute, even though I've knew for a while. Anyways, does this kind of coding work on a iMac?
Yes.
Okay. I just wanted to make sure that it'll work on iMac, so that way I can do it.
I used to also run this in a Raspberry Pi. I show how you can even move this to a very small device. And this is what we love about Python, that if Python runs there, when you work with simple libraries, kind of the core libraries, I'm not using anything external here, just threads, time, and sockets. You can run this from a Mac or from Linux or from other places. When I move to the next level, which is doing some computer vision, that is going to be a little tricky because you need to have OpenCV installed. And depending on the environment, OpenCV is not complicated anymore, but maybe tricky depending on what you have. But yes, this will run like this. You can run this in a Mac and it will work. So let me go back to the code and the stage. So next step for me was, okay, I can control the code, I can control the drone, sorry, I can access the drone. How about the camera? How can I access the camera? So I know that the camera will open in port 11,111. I start to play around a lot with a lot of tools, and I spent a lot of time trying to figure out what to do. Didn't work, I couldn't make anything work until I remembered, you know what? I know OpenCV, and OpenCV is an amazing library. OpenCV is a super popular library to work with images that was created by Intel a long time ago. You can do a lot of stuff. And hey, I love that working with the camera. For me, it was super, super easy. So let me show you, I created a new file, camera.py. I will add the general code, everything that we already seen here, sending function, receiving function, sockets, threads, everything else. But before writing the app, what I am going to do, I am going to start the connection with the drone. And remember that I need to send the command to say to the drone, hey, switch to the SDK mode. I will send another command, say, start the stream on. This will basically open the third port in the drone, and I will start to access the camera here. And to access the camera, I am going to do this basically with 2 lines of code. I know my port, I know my IP, I know that the port is 11.11.1, and then I am going to say, OpenCV, this is a library that I'm using, open this port. And OpenCV is amazing. OpenCV will resolve this, and OpenCV will connect to the camera. And by the way, here, if instead of use this, I set access to 0, it will access to my camera, the camera 0 in my machine, if I have USB cameras or embedded cameras. If I have 2 cameras, I can connect to the number 1 camera. If I want to connect to an RSTP to whatever HTTP camera, OpenCV will probably connect this. So with these 2 lines, I can connect to the camera, and then what I can start to do, I can start to get frames from the camera of the drone and iterate with them. So what I am going to do now, I am basically going to write this code when I'm going to have a loop, eternal loop. Remember, don't do this, sorry about this. I am going to read the battery just to have some kind of anchor with to the drone. And I'm going to, this is the magic happening here. I'm going to read a frame from the camera of the drone. I'm going to resize the frame. And then I'm going to show this in an OpenCV Windows. And if I press the letter Q, I'm going to stop the program. So super simple. I just need to add a final command, which is stream off. If I don't do the, if I don't do the stream off, the drone is going to get in a weird state. I need to take out the battery, wait a couple of seconds and start again. But quick recap here. I am going to open a video capture with OpenCV with the IP of the drone. I am going to do an eternal loop to get the frames and show the frames, and I'm going to close this. So let's go back here. Let's clean this. This is my new camera file, and if I am still connected, I am not connected, so I need to turn this on. So sorry about this. This is the demo mode. Come on. But it's good for me because I can drink water. So once it's connected, once I have my ping back, there it is. I can run here Python camera.py, and it's going to show this is just info from OpenCV. And what you are going to see in a couple of seconds, this is the drone camera. If I start to move the drone around, you can see how the camera is changing here. And sorry about this, you basically need to watch my camera and the screen at the same time. But hey, this is you there, you can say hi. This is all of you there. And this is a drone. It's super easy. It's, so go back here. You're all there in the drone view. It's super easy. 10 more lines of code, and this is super standard code also for us. And by the way, what you see there in my green screen is where I'm going to do the final demos flying around and recognizing the squirrels. we're in Canada, so squirrel, raccoons, and everything else is what we have here. But this is the code that we need. Open the video capture with the IP and the port that we know. This is the video capture that I have. And an eternal loop, read the frame, resize the frame, and show the frame. Someone asked, hey, how fast this works? How usually fast this works? So here, if I change this and I go for drone FPS, I have everything here. So this is the same lines of code here, but what I basically do here, if I check the time between frame and frame, do a crappy calculation here, and I get the frames per second. So if I run this again, I'm connected, yes, I will see that in a clean environment, my computer is there, the drone is 1 meter away. Right now, this is working at 240 frames per second. So it's super fast. It's really, really super fast. But again, this is just moving this. If I start to move the drone around, I start to process this, you will see here that gets down to 30, 40, 20 frames per second, which is still very good. I mean, this is what my kids love in their machine. They want to play games at, I can't remember the frames per second that they are looking for, but very simple code to see what we can do here. But hey, again, a couple of lines in the eternal loop to access the camera. And when we have the camera, we can start to do some stuff on top, like an example, calculate the frames per second, or even start to do face detection. And face detection, I am going to show you 2 ways to do face detection. First one is with one of the oldest. You can do a lot of stuff. When you have an image, and I work with this a lot, you can start to do object detection, detect facial features, you can do face recognition. There is also a full topic about ethics and how to do these kind of things here. I am just doing this. This is my little daughter. Every time I have the chance, I put my kids on video. So there is another conversation here. We can have it at the end or any moment about this. But I like about if you want to do something like face detection, you can use one of the oldest. And Amelia, yes, you have a question. Let me finish this and we can go with your question. You can go in the oldest algorithm detection framework that is available, which is the Viola Jones. It's more than 20 years old. And it basically, you pick up an image, you convert the image to a grayscale image, and then you apply a couple of algorithms that are going to try to detect the dark shadows that you have in your eyebrows and your nose. And with this, you detect the face. This is not the best one. I will not recommend to use this on production, but it's nice. It's good to start because it's part of the OpenCV kind of starting kit demos that you can use, and it's super easy to use. You basically pick up an image. We have the image in the eternal loop for the frame, and we apply, hey, see if you can detect the face. And if we have a face, we are going to draw a frame around the face using this technique. Again, it's not the best one, but I think it's a good one to learn. So let me create this face PI file. And yes, Amelia, you have a question, please, if you want to raise your question.
Is this certain recording on a social platform? Because I would really like to watch this after I play a VR game or something.
Yes, and I responded, Amelia. That's a good question, and thank you for asking. I responded to your question in the chat. We have a YouTube channel. PyLadies SWFL has a YouTube channel, and usually it takes me about a week to upload the video, sometimes sooner. And okay. I will let everyone know who has attended today when the video is up. Okay.
Thanks. I'm sorry, I didn't scroll down to see that you have right the answer there. There was a question and the answer. So, hey, going back here. So, new file, face PI, the common code that we already seen with everything that we have here, including the video capture. But let's add this. This line is going to create what we call a cascade. And this cascade is a file that is part of the SDK. It's an XML with a lot of info there. And this is the one that we are going to use. We are going to pick up the image from the drone. I'm going to say, hey, cascade, do you detect the face? Once we have the results, we can show a frame around this. And I need this XML. So let me also copy this XML. Copy the XML to our folder. There it is. And let me close this. It's a very big file. And then the code that I already showed. So I am going to create a loop. I am going to resize the frame, 640, 480. I am going to, the next lines are going to convert the code to a grayscale image. And then I am going to use this cascade to say, hey, do you detect something here in the new converted image? And I am going to have an array with the 4 boundaries of the, with the 2 points for the frame that we want to draw. And I am going to draw the frame here using OpenCV. So super simple. Again, it's kind of growing on the previous examples. So let's run this one here right now. Let me see, I am not connected, so connect again. And in the meantime, just to show you here, this is the new face file that we just created, the new XML that I copy here. And if I am connected, not yet, I can run the face detector. It's connected, so there it is. I can go back here and say Python, sorry, face.py is connected. It's going to open the camera anytime soon. Where is my camera file? There it is. And if I get disconnected, no, there it is. If I put this here pointing to my face, you can see there how it's drawing a frame here with this. And if I even turn this and got it there, it started to detect some faces. It's not the best one, so detect mine. Detect another one. So detecting a couple of faces. This is, I didn't plan this, but this is kind of a live demo. And hey, it works. It's kind of nice. It's what we can do here. And again, once I connect to the drone and I control the drone and I can access to the camera in this eternal loop, I can start to do a lot of stuff. So I can pick up the original frame that we have from the camera and I can detect faces. I can even get, I have other faces, other demos that instead of using the hard cascades, they use a retrained deep neural network, which is much more, I don't have the banana here, much more complex. I have another one which is going to detect bananas. Why? Because I used to have a banana nearby and I use the banana to detect this. And the last part to show you here, what I did is I use, where is my browse here? Not this one. I use this platform, which is called Custom Vision. It's part of the Azure Community Services, which is a set of services to do machine learning. And you can get here and you can train your own object recognition model. So what I did is I upload tons of images of squirrels and space marines, because I have these two in the back as jokes. And you can basically put your images there and start to draw boxes. This is a space wolf. This is a space wolf, a space wolf, a space wolf. Or here should be, this is a squirrel, this is a squirrel, this is a squirrel. And with this, I have here 40-something images, 42 images, maybe less because some of the images has 2 objects in the same image. And when I have everything here, you can train this object recognition model and you can use it online. You can train this, it's going to train on the cloud, you can try this for free, and you can even upload a photo and it will say, hey, this is a new photo and we detect here a squirrel. So you can trust it, training online. What I really like about this, and there's tutorials, there is a lot of stuff here, is that you can also export this trained recognition model as a TensorFlow which is a super popular object framework to do machine learning globally as Onyx, kind of a standard, but you can also do this as a Docker file. What is cool about this? That this will export a fully functional Docker image that we can build for Linux or for Windows. Nobody uses Docker in Windows, but hey, there it is. And you can run this. So what I have here is I export the Docker image for recognition for these squirrels, and I have the Docker image running here locally in my machine. So I have right now, if I run this app, I have a web application, which is going to run locally in the port 80, and I can post image there, and it's going to return me a JSON with the recognition of stuff. So I can go here, and if I open Postman, I don't have Postman. I don't know why it's not working on my machine. So I use this software, which is called Insomnia. It's basically the same. It's a GUI app that allows us to simulate post. And I can get here, let's choose this. I will choose a file here. And here in my, I have here running locally, 80, and the endpoint is image. I can make a post here. Yes, I know I don't have the trial anymore. I can make a post. This is going to upload. You see it's working on the back. And this is the result. I am going to have this info. I know that I have this tag, space wolf, very high probability, 99%. This is between 0 and 1. And this is the bounding box. This is the location in the original image where this was found. And I will probably have other space wolf with a very low probability. I don't care about this. And I have this running as a web app here in my machine, so I can use it here. So what I did, I create, based on this camera demo, I have here my squirrels demo that is going to basically do everything that we did right now. And if I enable the detection, I will press the letter D to enable or disable the detection. I am going to make a post with the image to the make a post with image with the local URL, and then display the predictions on the camera, on the camera view, and show the frames per second. And I have here, if I press the letter D, I will enable the table, enable and disable the detection, and also have here my controller of the drone. Remember that I told you that I'm going to do the flying demos at the end. This is the flight demo. If I press the letter T, the drone will take off, L will land, W, and I will use the standard ASDW to move the drone around. So let's run this. Let's hope for the best. This is the moment that everything breaks. I hit the drone with the wall, and this stuff happened. So my app is running on the recognition application is running on the right. I am going to start. I'm sorry, this is turned off. It's not going to start. Start the drone here. As I get the ping connection, I am going to start the drone up, and I will move my drone here first, man, with the hand to show the squirrels, and then I will try to make it fly. And I hope I have a big camera view, and I hope that I don't hit anything important. So let's start the drone. Start in the air. There it is. If I move the drone, I am starting to move the drone. Refresh the camera, something happened with the camera. Probably need to, this is happening when I didn't close the app right. So let me close the app in the correct way. Get stuck here. Oh, come on, demo. Okay, let's start this again. Sometimes this is happened when I didn't close, I didn't send the last command. I am moving the drone around, but it's not refreshing the camera. This is usually because it didn't get Well, disconnected. So taking out the battery, waiting 5 seconds.
I'm sorry, Bruno. Is this because of the stream off command that wasn't sent?
Yeah, sometimes if the stream off is not well processed, this is what's happened with the drone. So I take out the battery, wait a couple of seconds. And also remember, this is a toy. This is not supposed to do, you're not going to use this in production, or you are not supposed to use this in production. It's up to everyone. But yes, if the last command is not well processed, sometimes the camera get in this weird state and we need to reset this. So let's connect again. Sorry about that. This is probably the first time that I do 5 demos on a row working. I usually get this error in the second one. So I was hoping, oh my God, this is going to be the one that is going to work all, but no.
The next one will.
Hey, next one. Still broken. Where is my camera? There is the camera. It's not refreshing. Super annoying. Sorry about that.
Is there any chance the IP address might have changed?
No, it's the same. I know it's the device. It gets in this crappy, weird state. Just need to wait a couple of seconds until it gets. Let me change the battery. But it also gets kind of hot. And I turn this on right here. Start to try to connect. One more time. There it is connected. Connect to the camera. In the weird state. And it's not going to show anything here. Sorry about that. Okay, now I have one squirrel detected. So there is doing the detection. Sadly, it's not refreshing fast enough. If I move the drone around, it's not refreshing, but what is happening there, and you see it's, stop the detection. It's getting the camera, doing the detection and showing the bounding box. I just move the drone a little. Come on, stop. We can also see the space wolf there. One more time. Start the detection here. Take a couple of seconds. You will probably start to see both of them, the squirrel and the space wolf detected there. In the meantime, this app, it's also saving in the location of the detection. Come on, start the detection. Click the while to see if it's finished watching the stuff here. If I go back to the to the folder, it's saving each image. So I am saving each one of the saved images here, and it's also saving the detected one here. So we can see here what we have. I am saving this, and I can even do the recording of video. So it's not recording yet, it's not finishing, and also not working the detection. Sorry about that. This is what's happening in live demos. There it is. So that's, I enable this. Right. You can see that sometimes it's also detect the squirrel. It probably depends on the lights and something else. Stop the detection, started again. Sadly, if I move the drone is not picking up the final demo. Oh my God, this is super annoying. Okay, let me do one more super quick test, which is let's open the instance drone here. Hope that we are connected. Oh, I am not in. Go to reactor. Sorry about that. Last test to see if it's working. Same state. No. Same state that we were before. Drone is crazy. But that's kind of the idea. So sorry about that. Let's give it a try to finish. And before we end, just a quick recap of what I show. We write, we do, we build or whatever, a drone SDK from scratch, writing these lines of code. For me, it was a great experience. I learned a lot with this. Sorry about the colors. I just realized that the standard palette, it's super ugly. The second line with the drone telemetry, this green is not very nice. I need to switch this to a better color palette. So sorry about that. But hey, drone SDK, get the access, get information from the telemetry, then do the camera. And when we access to the camera, we use an OpenCV with the tech faces. And I'm not going to do the Azure IoT. That's completely different set of stuff. And everything that I did today, oh, sorry, that's the wrong letter. Everything that I did today, you can find it here in these slides. You can find the drone, you can find the SDK. Again, not the SDK, just the PDF. And I write a lot about this in my blog. If I go here and I open this, I write a lot of articles about how you can do this. And you can see here that Python, how to connect to the drone, reading data from the drone, everything that we did today, and a couple of more other samples are in this blog. And today, before we launch this, I even show the final demo that we did today, and I have all of the code here available if someone wants to access. So this is basically me. Sadly, this is literally not working anymore. It's not even refreshing, so it's probably broken. Sorry about that. This is my crappy drone, which is basically going to die. And hey, I will open the floor for questions. If you have any questions, if you want to contact me or you want to check this, the best way is probably via Twitter. And all of the samples or everything else is in my blog and Bruno.com.